So I want to make a series of videos to help people prepare for this math test, the Praxis 5165 math test. I think for most people, the purpose of the test is to get a secondary teaching certificate. It's like you're trying to teach high school or something. Anyways, I looked around online a little bit and I found some practice tests, and I may go through and make videos for them too. But before I got to any of that, I thought it made sense to start with kind of the official practice questions they have in the study companion put out by ETS. So if you scroll down to the bottom of this thing, you'll see a bunch of sample test questions, 17 of them, I think. And while they post answers to these sample questions, I thought seeing the answers in video form might be useful. So I'm going to make a separate video for each of these 17 problems where I answer the questions, but really try to make the goal more teaching the kind of things that you'll need to know for related questions to do well in the test, as opposed to just answering the questions that they give you. Often there'll be multiple ways to solve these problems. I'll try to pick one or two that I think are the most efficient or easiest. But if you solve it differently or think of some method that might be useful to other people trying to take this test, maybe make note of that in the comments. I'm going to try to keep the videos pretty short, so I definitely won't be solving these all the different ways you could solve these. Anyways, question 1. So I'm told that x and y are even numbers and that z is equal to 2x squared plus 4y squared. And what I'm supposed to figure out is some information about z. In this case, what is the greatest even number that must be a divisor of z? So one option, since you're lucky enough to have a calculator, is you could just sort of arbitrarily choose some even numbers for x and y. So I don't know, x is 2 and y is 2. X is 2 and y is 4. X is 4 and y is 2. X is, 10 and y is 10. And then you can calculate what z would be equal to in each case. All right, 2 times 2 squared is 2 times 4, which is 8. Plus 4 times 2 squared is 4 times 4, which is 16. 8 and 16 gives me 24. Similarly, if x is 2 and y is 4, I get what? 8 plus 64, I think, which is 72. If x is 4 and y is 2, I get 32 plus 16, so 48. And finally, if x is 10 and y is 10, I get what? 200 plus 400, I guess 600. And then you can look at your list for z here and be like, they're all divisible by 2. They're all even numbers for sure. Are they all divisible by 4? I don't know, maybe you need to pull out a calculator or something, and you'll figure out that, yeah, in fact, they all are divisible by 4. Same thing with 8. Sure enough, all these numbers are divisible by 8. Then you get to 16, and maybe you'll realize that they're not all divisible by 16. 24, for example, is not divisible by 16. So it appears that 8 is the largest even number by which all of these z's are divisible. That's the right answer in this case, but that's not a great way to solve this problem, because maybe by dumb luck, all these numbers were divisible by 8, but if I had chosen some other even numbers for x and y, I would have come up with some value of z that's not divisible by 8. It's conceivable that there are even numbers for x and y that leads me to a value of z that's divisible by 4 but not divisible by 8. Turns out that's not the case, but using this method doesn't really guarantee the right answer. I mean, it's better than nothing. If you don't know how to solve a problem like this, plug in some numbers, come up with a good educated guess, and move on. In this case, you would have gotten it right. But I think a better way to solve this problem is using a little trick, and that's rewriting even numbers as 2 times some letter, n for example, where n represents a whole number. A useful trick on problems like this is if you're referring to an arbitrary even number, rewrite it as 2n where n represents a whole number. And if you're referring to an arbitrary odd number, don't rewrite it as 2n, instead rewrite it as 2n plus 1 or 2n minus 1. It really doesn't matter. How does that help? Well, remember, z is equal to 2x squared plus 4y squared. But since x and y are both even numbers, instead of writing x squared and y squared, I could write, 2n squared and 2m squared, just picking whatever letter I want, but representing them in this format that I use to represent an arbitrary even number. If you've gotten this far, now just simplify to get rid of all the parentheses. To get rid of these parentheses, I got 2n times 2n, in other words, 4n squared. So I got 2 times 4n squared, in other words, 8n squared. Similarly over here, I got 4 times 4m squared, in other words, 16m squared. And since I'm interested in numbers that can divide this thing z, maybe it makes sense to factor out as much as I can from each of these two different terms. I could factor out an 8 from each term, and I'd be left with n squared plus 2m squared inside of the parentheses. What I'm saying is instead of writing z in terms of x and y, where x and y are these arbitrary even numbers, I can write z in terms of n and m, where n and m are just whole numbers. Why is that useful? Because in this format, it's obvious that the thing that you'll get will be divisible by 8. If what were inside these parentheses happened to be even, then this thing z would be divisible by 16. But I don't know that this thing inside the parentheses is even. For example, if n is equal to 1 and m is equal to 1, then this is 1 plus 2, in other words 3, it's not even. Oh right, if n and m are equal to 1, then x and y are equal to 2 times 1, in other words 2. And if x and y are both equal to 2, we've already seen that this thing z would be equal to 24. This 8 times the 3 you'd have left in the parentheses. Anyways, what I'm trying to get at here is I suspect this is the way the test makers want you to solve this problem, but it relies upon you recognizing that when you talk about arbitrary even or odd numbers, you want to rewrite them as 2n or 2n minus 1, which I suspect a lot of people wouldn't think to do. But if you can do that and you're really good with your algebra, you might see that this thing is divisible by 8, but not necessarily divisible by 16. If you don't see that, you can come up with an educated guess by just throwing in some arbitrary numbers for x and y. And if you don't like either of those two methods, you can kind of talk yourself into the answer if you recognize that an even number squared has to be divisible by 4. So since x is even, x squared is divisible by 4. And something that's divisible by 4 times 2 is divisible by 8. Similarly, because y is even, y squared is divisible by 4, and something divisible by 4 times 4 is going to be divisible by 16. So z is the sum of these two numbers. One of the numbers divisible by 8, the other number is divisible by 16. If you're adding up something divisible by 8 and something divisible by 16, you're guaranteed to get something divisible by 8, but you might not get something divisible by 16. For example, if those numbers are 8 and 16 themselves, they'd add up to give you 24.